All right. So I just wanted to put here the agenda again. So basically, right now we move on to the evaluating LLM-based applications, which I'm going to talk about now and a bit after lunch. So the topic right now is moving further to evaluating LLM-based applications. And before I go and tell you everything about it, just a short introduction from myself. I'm Festina. I'm also a consultant at Netlight. Same as Pablo, I just put some buzzwords here. I'm mainly focused on data engineering, data science, also quite some bit of experience with GenAI, and also MLOps. When it comes to my background, I come from a software engineering experience, actually, where I worked after my bachelor's studies as a software engineer for a couple of years, but then moved to the data world 5 years ago, where my focus has been mainly on machine learning, computer vision, but now GenAI, and also heavily involved in cloud infrastructure as well. So enough about me. Let's start with the topic. So what I want to show you is why, first of all, why I want to talk about this topic of evaluating LLM applications is that I am myself working with different clients in the healthcare sector. Right now, I'm developing the third GenAI applications for a very big client in healthcare industry. And one of the main things there is evaluation, because you don't want to generate anything in such an industry without evaluating first the outputs. Same cases in finance industry, for example, but all other industries as well. However, in this slide, so how I want to start with this information is basically the development complexities of LLM applications. And also just to clarify here, why am I using the word LLM applications and not LLMs themselves, is that it's evaluating LLMs, the models themselves, is a complete different story than evaluating LLM applications. When you're trying to evaluate LLM applications, what is important is to know what are all the inputs that go into an LLM and what are the outputs that go out of the LLM. What I mean by this is that, for example, for inputs, you can have so many different LLM parameters, like you have temperature to control, how much do you want the model to hallucinate, and so on. And there are a bunch of parameters out there that you have as an input when it comes to these, to using these LLMs. Furthermore, you have prompt templates. As we saw, for example, from Pablo's presentation, you have these auto-generated prompts from Microsoft for the RAG application, and you have different prompt templates, like the way how you instruct the prompt. That is also an input to the LLM. Another input is different chains. So when I say chains, I mean there are different LLM nodes out there. For example, you have different prompts in nodes, and then that is also an input to your LLM. And RAG parameters, and RAG context data, and fine-tuning data, and so on and so forth. And when it comes to outputs, you have text summarization. That could be one use case. You have text generation. You can chat with the model. You can question and answer the model. You can do code generation with the LLM. So you have all of these outputs that are use cases, and you have all of these inputs. But since they are very specific and you have tons and tons of use cases, how do you evaluate them? Why do you need evaluation at first place? So here I pointed out basically three key points when it comes to importance of evaluation. The first one is that evaluating LLMs help us better understand the strengths and weaknesses of LLMs. Like, where is a language model will support us for sure? Where is the weakness? How can we improve that? Also, the second point is better evaluations can provide better guidance for the human and LLM interaction. This I see also in my day-to-day work. because developing workflows with language models, it really requires you to think about different approaches, top-down, bottom-up. Evaluations, which we will see later, can help you also guide you how do you build such applications, what is your workflow there. And the third point, as I mentioned before, is that in healthcare, finance, industries, evaluation is crucial. You cannot put any LLM applications in deployment used by real users without having an evaluation process there. Also here, so I just wanted to showcase, for example, all the prominent leaders that there are out there, such as Andrej Karpathy and Greg Brookman. They also highlight how important is evaluation, and sometimes evaluation is all you need. And another research that I did is just to see, so I read a couple of research papers out there in this topic. And one of the research papers mentioned basically the number of papers in LLM evaluation topic. And we see this exponential growth here, especially in the last year. You see how many research papers are being developed out there in this topic, which highlight also the importance of evaluating LLMs. What I want to talk next is basically, what is this blueprint? How does one start evaluating LLMs? What is important to consider? Because there are tons and tons of metrics out there. There are tons and tons of courses and webinars and whatnot, like research papers. Where do you start? Where does one start? So I put here very simply, all you need is good evaluation data and good metrics. So when it comes to evaluation data and metrics, this is basically a quadrant graph that I put here, is that better data and better metrics, you can reach better evaluations. And I just want you to think about this quadrant. What is, for example, if you get quality data and quality metrics, that is costly. So for example, what I see also in my day-to-day work is that if you want to use public benchmarks out there and just get, for example, I don't know, some LLM applications, let's say you're doing code generation, and you see out there, which we will see now in a bit, Cloudy, for example, is one of the best models to do code generation with. And you say, OK, I want to test Cloudy now. I have this very specific use case to just generate code for this piece of context. However, you say, OK, I'm going to use it. It looks promising. But then your use case is so specific. How do you know that it's going to work for your use case? And the ultimate case is that you have a human evaluating that shows, OK, this is wrong, this is right. But that is very costly. You have also another point that is here is user testing. With user testing, you can say for each generated output, you can have, for example, a different way to receive feedback from the users and then process that feedback somehow. And you have tons of also auto-evaluation tools out there. But the main idea is that involving humans, maybe it's the best case scenario, but that is very costly. And that's, as I mentioned, I also see that in my day-to-day work, where we are generating, for example, outputs for the healthcare industry. And if we have humans out there that say, OK, this is bad and this is wrong, and that will guide us how to make the prompts better, that is the best case scenario. But usually that is not the real case. And when it comes to benchmarks, so I mentioned it quickly, what about benchmarks? Because as I said earlier, there are out there so many options that you can check, like so many models, so many metrics. Where does one start? So for example, there is this page now recently deployed, is this artificialanalysis.ai. And here, for example, in this website, you can see all different models, where they are good at and where they are not good at. For example, some of the highlights is that quality, GPT-4o, for price, Llama 3 is the cheapest. And when it comes to use cases, for example, you see general ability, reasoning, and knowledge. For example, GPT-4o is the best. And when it comes to coding, You have Claudie in the leaderboard here taking the first place, and so on. So you can have also, there are different ways of categorizations here. For example, which model is best to use for healthcare, which models are not for this use case and that case. So you see there are benchmarks out there, and I highly recommend going here, for example, just to get an overview of all of these models. But what about these public benchmarks? Like, why can't we just go and use it? Why do we need evaluation? The idea is that with benchmarks, what is the problem is that they often fail to reflect the performance of your specific use case, as I mentioned. They also do not account your unique prompting methods, and they do not account with what kind of data did you fine-tune the model, what kind of in-context learning are you doing. For example, as we saw for our specific use case, which is a simple reg with the policy data, and you say, okay, this is a reasoning application. Why can't I just go and use GPT-4o because it works? In the leaderboard, it was the highest. GPT-4o is so like generic that, let's say, if you want to evaluate specifically that if you ask the model that the word mango should be used or not be used, you cannot just rely on, for example, GPT-4o to tell you that, like that is always correct, because sometimes it can fail. And I will show you cases, but basically, if you want to make sure, you need to have a reliable evaluation pipeline in your, after generating your outputs. So going further, back to the blueprint. What I said before is that all you need basically is evaluation data and evaluation metrics. What is the idea here is that the best pipelines out there is that when you have your own evaluation data. And when it comes to how to build these evaluation data, like how does one build evaluation data? For example, we saw now we have that RAG application that works with the Mango use case, and we want to have an evaluation pipeline there. Where do we start? Building the evaluation data, but where do we start with this? So the idea is that you start small. You can also utilize LLMs for assistance, and the idea is that you incorporate additional data even after deployment. So one highlight that I want to emphasize here is that evaluation data is not static. It can only get better. And the reason why I put the third point is that even after you're deploying your application, you have your evaluation pipeline working, you still need to get more and more data, more and more feedback from the users to enrich your evaluation data set. So now I'm going to show you basically how do you start small, and what is this start small basically, what does it mean? So let's say, for example, I took an example here. I want to have a use case where I generate marketing campaigns for a specific channel. This is a prompt, okay? So you say, write me a marketing campaign for LinkedIn, Facebook, and so on. You want to know how, you want to evaluate if these marketing campaigns are suitable for your use case, are they correct, and so on. The main idea is that what you start is that you are building these applications. You want to first chat with the model. You want to first ad hoc test the model. Say, okay, what kind of answers am I getting? If I write this prompt, what answer do I get from a model? Just to get some intuition there. And the main idea is that when you do this, what do you want to do is that you want to anticipate more complex queries, more complex prompts. What do I mean by this is that, let's say you're building this application for generating marketing campaigns, and a user might say, write me a marketing campaign towards target group X, incorporating current trends and historical analysis. From your own testing, if you tested the application, just write me a marketing campaign, and you saw that it works well, you say, okay, this is good, my application is good. But you didn't anticipate that the user can write these kind of prompts. And there you can see that the model is hallucinating with something, or just not really showcasing, for example, how the target group is involved there, and so on. So the main idea is that when you start building your own evaluation data set, you want to at least have, let's say, 5 queries, 5 prompts that have these hard or this diverse examples that will balance your data set in a way. And then after building this, which we will see later, you run your model for every example, and you see the answers that you're getting. So the second point is that you can utilize your LLMs for assistance. This is a bit less manual. And how you can do that, I put here one example with planets, because I also wanted to be an astronaut when I was a kid. So basically, you can say you are a small smart assistant designed to help high school teachers come up with reading comprehension questions about planets. Given a piece of text, you must come up with a question and an answer pair that can be used to test the student's reading comprehension. So when coming up with this question-answer pair, you must respond in this format. On the right side, you have basically what the model has generated for me. So you have the text, and you have the question and answer pair. It generated some text to be used as context, and you have the question and answer pair. So basically, with this, you see that, OK, we kind of are developing our own data set. However, if you go this path, with LLMs, what is difficult is to generate these diverse inputs. As I said earlier, the main idea is for you to be able to generate more diverse inputs and more balanced data set, and usually LLMs don't give you that. The third point is incorporating additional data after deployment. In my day-to-day work, for example, in the healthcare industry, what we have in our pipeline is that we get user data from, let's say, a user is prompting something, they get an answer. We have a certain way, for example, how to get systematically the user feedback, because that helps us improving the prompts later on. So you want to capture feedbacks in a systematic way. You want to know what the user disliked, what they liked, where did the model fail. For example, if one sentence in the whole generated output was not even in the documents or so. You want to know that the users find the answers accurate and so on. So you want to cluster the feedback in the end in underrepresented topics, intents, etc. So when you have that feedback, you know where you want to improve your whole, let's say, your prompt flow or your RAG application. And going further, what is usually included in an evaluation data set? So I told you a bit about that it's important to have the small data set. It's important to have these diverse queries there. But what is the data model in the end? What is included there? And this basically highlights the key points, because this is what we're going to do also the exercise with. You have the input type, which is the user query. You have the response, the output generated from the LLM. You have the instruction, which is basically part of your prompt in the end. It's your prompt, so the instruction is the prompt. You have the context. Context, for example, as Pablo showed you, those retrieved documents can be the context. For example, sometimes you don't need context. Maybe you just want to know, you just, for example, want to get what the model knows. In RAG application, you will need to use context. So these data also can be empty. But the idea is that you have also this reference in the end, so the ground truth to compare your LLM response to. This you can have. It's sometimes costly to have. But if you have this, it really shows you, for example, that, OK, you generated an output. You want to know if that output is somehow similar to the ground truth that you would expect. So with this, we encapsulate the idea of how to get around building evaluation data sets. And back to the blueprint. So again, evaluation data, evaluation metrics. Now we have in our minds what it entails to build an evaluation data set, like as I said, hard examples you need to be in your database, and there is this input data model, for example, that you want to have and include in your data set. But as I mentioned earlier, your evaluation pipelines gets better if you have good evaluation data, but also good evaluation metrics. Now, in the second part, I just want to cover this evaluation metrics because out there are so many evaluation metrics, for example, and where do you start? How do you structure your brain also in this aspect? Before going in further details, I want just to highlight what are LLM evaluation metrics. So on the left-hand side, we have LLM test case. This is your data. So as I said, in the data model, you have the input, you have the LLM output, the response, you have the retrieval, the context, etc. What does LLM evaluation metrics entails is you have a scorer and you have a threshold. So for example, you want that if the answer is correct, you want to have a score associated with that. For example, you have from 1 to 5. 5 is the best. 5 is, for example, the answer is correct, and 1 is not correct. So you want to have a score associated to it. And when it comes to threshold, it really comes down to you how you define it. So the other thing is you have the score, but you can have also the reason. So I'm going to show you later, but this is actually important because let's say you're using LLMs to do your evaluation, and they come up with a score of 4. Why did they come up with a score of 4? The idea is that you can have this chain of thought prompting techniques which can justify why the model came up with that score, for example, which we will see in a bit. So this encapsulates the basic of what is an LLM evaluation metric. And the important part that I wanted to emphasize is that good LLM evaluations are reliable. When it comes to metrics, you want that your evaluation pipelines are reliable. That's the main takeaway. And how do you measure this reliability? When it comes to LLM evaluations, LLM-based evaluations, the main idea here is that you want to measure the quality. So do the metric predict the quality that the users expect? This can be interpreted in so many different ways. But what I want to say here is that when users are using your LLM-based applications, they expect that the results are correct, for example. In our case, with the RAG application, we wanted that the answers to be retrieved from the context so that the answer is correct. That's what the user expects. And that is one LLM evaluation metric, answer correctness. The other thing that you may want is that for the generated responses, for example, you're generating marketing campaigns with your LLM applications. And you have 3 years of data with marketing campaigns. You want to see, for example, if this generated marketing campaign somehow is similar with the generated campaigns that you did before. Because this assures you that, OK, the LLM is not doing something crazy. So again, that can be measured by semantic similarity between the two generated outputs. And this is how, for example, when thinking about evaluation metrics in LLM applications, you think what the user wants, and you somehow translate those wishes to metrics. So that's how these evaluation metrics were developed, for example. And yeah, accuracy, as I mentioned before, is highly important. And how do you measure it? There are plenty of ways also to do that. Going further, what I did is that I checked so many research papers out there. As I mentioned earlier, they are growing exponentially. When it comes to metrics in general, in machine learning, deep learning, and LLMs, there are so many ways how to categorize them. You have so many research papers saying, OK, this metric is from traditional machine learning metric, but you also have metrics that use LLMs, for example. That's one way to categorize them. And what I found with this intrinsic and extrinsic categorization, I found that it encapsulates this, what I said, when you think about LLM-based applications, you want to think about what the users want. And when it comes to this intrinsic, for example, this categorization assesses a language model's ability to generate coherent, meaningful sentences. This, for example, is useful to evaluate the language model itself, but not the language applications. And extrinsic evaluations, they measure language models' performance using user perspectives and real-world context. So this is what we want, especially for our use case, for RAGs, for example. We want to use this kind of metrics. And some of them are, for example, in the intrinsic, you have metrics such as BLEU, such as precision, F1 score, and so on. These are very familiar, also used in traditional machine learning metrics. And for extrinsic, you have trustfulness, usefulness, accuracy, groundedness, which we will go further and explain. But basically, this is what you want to look at when you are especially developing RAG application for your production use cases. So now we know a bit, okay, there are different categories, there are different clusters out there. We know a bit how to think about it. How then do we make the decision when to use what? This is also something I came across. It's basically a framework to show you how to think, what questions to ask. And the first one is that, for example, you want to see, is there a correct answer? Is the answer correct? Then if it's correct, then you use, for example, metrics as traditionally in machine learning, for example, accuracy metric or F1 score. For example, you're labeling data with your LLM, and you have some ground truth labels, for example, 100 ground truth labels, yes, no, for different questions, and you have LLM labels. What you can do is just use accuracy just to test, for example, how many misclassified labels are out there. If not, then do you have a reference answer? As I mentioned before, you have these, let's say, generated marketing campaigns. You have a whole data set with your previous marketing campaigns generated by people. You want to see how you can check that, and that you can do, for example, with this semantic similarity and so on. And do you have feedback on the previous answers? Did the user give some feedback? How do you incorporate that as well? So that is also a question you can think of. So the key idea when it comes to these metrics that are used in LLM applications is that usually to measure this semantic similarity, you would use another LLM. So the key idea is that you use LLMs to evaluate LLMs. And the question is, how do you trust them? Why would you use them? Which we will see later. But basically, what is being done is that for semantic similarity, you use, again, GPT-4 to say, OK, these two texts are similar or not. Or you use other embedding models that we saw to measure the similarity, for example. Other cases are these basically static metrics. I wanted to highlight this because when developing real-based applications, what is important is that you want to control the output. For my use cases, what I'm building is that I have these tons of different nodes with prompts, and each prompt gives me an answer that I will use to the other prompt. But if I am expecting a JSON, if, for example, if the prompt or the LLM is not giving me a JSON, then I will have errors in my code. How do I automate my flows? So I want to see how can I also evaluate that the JSON is formatted, that the JSON is in the correct shape. And there is this concept called function calling, which is highly relevant in this use case. Also, you can ask the model to grade the answer on a scale from 1 to 5, but we will see that sometimes the language models, they prefer a number, let's say 3 or something, So that's not very reliable. Here, I wanted to showcase an example. So I mentioned a lot this semantic similarity. There is this library out there called Ragas, which I highly suggest to check. It's really straightforward, open source, where you can use to measure, for example, the semantic similarity between two outputs. So the idea is that, for example, you have your question, you have your answer, and you have your ground truth. And how do you measure the semantic similarity? You can just do it straight away with this Ragas, and it's basically 2 lines of code there. And that will give you the semantic similarity between are they far away or very, very similar. So in terms of steps, what it does internally is that you vectorize the ground truth answer, you vectorize the generated answer, and you compute the similar cosine similarity. Same as when we did the RAGs, for example, when we are checking if the query, embedded query is getting the right context data, and that is done with cosine similarity as well. Almost the end. So what I want to leave this session with these 2 questions. Can we evaluate LLMs automatically? And are LLM biased evaluators? When it comes to the first one, it's really, I mean, that's the difficult part. Like, what is the best case? You want to have an evaluation pipeline that runs automatically, and based on the results that the evaluation pipeline gives you, you want to improve the prompts automatically. For example, let's say if the answers are not correct, you want to improve the prompts better so that they give you a better response. And if you have that all automated, then you're in a perfect shape. But that's really hard to do, and it's very difficult even nowadays with all of these tools. And the other question, or LLMs biased evaluators. What I had a use case in my experience is that we were using LLMs to label the data. For example, the use case was generating classifying social media posts of diabetes. And what the evaluators did was that they said, OK, this post is related to diabetes. This post is not related to diabetes. What we wanted to do is build an LLM application, a RAG, basically classifying, like the output would be true or false. And we saw that, OK, for some use cases, the LLM would say, OK, this post is related to diabetes, and the ground truth label from the humans was not. And when we were checking why not, then the human labeler was saying, but maybe this is actually related to diabetes. Maybe I thought something different. So you have humans as labelers, which can be biased, but also the LLMs can be heavily biased. And some of the research paper mentioned that, for example, LLMs tend to prefer single numbers, and models prefer their own outputs, and they prefer longer responses. So these are basically what they can be biased to, but from my own experience is that it's hard to control the bias when the humans are biased as well. So with these 2 questions, I want to end this part of the class, and later on we will move to the exercise, which is still tailored around this building your evaluation data set and how to choose the best metric. But I hope it gives a blueprint on how to think about this topic in general. So yeah, that's it. Thank you. And we can have questions. I don't know what is the time. We are a bit fast, but yeah.